Hey everybody, this is Mr. Bells here. This is a video for Data A. It's our first unit. One of the things I want to talk to you about today is quadratics. You'll probably see some videos with me in front of the camera. You'll probably see some videos of me just putting some stuff down on paper for you. This is pretty basic stuff. I'm hoping that we're going to be okay with this. But as you can see right here above my head, perseverance. Perseverance means being able to stick through it more than what you maybe thought that you could, even if it gets frustrating with this distance learning stuff. I'm going to be here to help you. Hopefully you're going to stay with it and work as hard as you can. So here we go. There's some stuff on factoring. We're going to start with some basics right here. So first off, let's say that I have a number like 24, and we want to know just what its factors are. Okay, so factors are numbers that multiply together to get 24. So 4 and 6 could be a possibility. If I break it off here, 2 and 12 could be a possibility. If I break it off here, I can go 3 and 8. And if we went into partial numbers like fractions, then we'd have an infinite number, but there's only so many whole numbers that this works for. Of course, the basic one right here, 1 and 24, also work out. So these are what factors are. Again, factors are anything that multiply together to get this number. So then we have something called, okay, let me write this out. So those are factors, or factor pairs. Then we have something called prime factors. Prime factors are factors that are just prime numbers, and prime numbers are only divisible by 1 in themselves. So let me give you a quick little rundown of some prime numbers again. 2 is the only even prime number. 3, 5, 7. I can't use 9 because 9 is divisible by 3 and 3, but I can use 11. I can use 13. I can't use 15 because 15 is divisible by 3 and 5. Remember, primes are only divisible by 1 in themselves. And that's why I can't have any evens either, because every other even number is also divisible by 2. So 13, 17, 19, and then I'd ask you, does 21 work? And most of you go, nope, 21 doesn't work because that's 3 times 7. And 1 times 21. So again, prime factors only divisible by 1 in themselves. So when we're doing a prime factor with something that's called a prime factorization, that means I need to break down a number into all of its prime factors. So I'm going to show you 2 ways that we do prime factorization. So let's start with the number 24. And one of the ways I can do is list any of its factors. So in this case, 4 and 6. And when I do 4 and 6, I know that that multiplies to 24, but I got to still break these down. So if they have any factors, I need to break them down again. So 4, of course, breaks down into 2 and 2, and 6, of course, breaks down into 2 and 3. And now you can see that all of these bottom trees of numbers, right here, these bottom roots, these are all prime numbers. So once we've had it so it's just a listing of the prime numbers, then we call that a prime factorization. So 24 is equal to 2 times 2 times 2 times 3. Those are all of its prime factor breakdowns. Another way we could write that is 2 to the 3rd power, because 2 times 2 times 2 is 2 to the 3rd. That's what an exponent is for. And times 3. Okay? So what I would like you to do, see if you can do this right now, I want you to try a prime factorization. Let's try it on, say, we'll go 63. Okay, so stop the video for just a second, see if you can break that down. Again, 63 prime factorization. So again, if you didn't stop the video, stop the video. Try it on your own. Maybe you're that quick. But hopefully you're back now, and now I'm just rambling. So here we go, 63. I know that some of its factors are, and you probably didn't do this, but I know that it's that. 3 times 21 is 63. And I go, hey, is 3 a prime number? And I look over at my prime numbers, and I go, yep, 3 is a prime number. So that one's done. Is 21 a prime number? And then I go, I don't know, I didn't list them all down over here. But I will tell you 21 is not a prime number, it's factorable. 25, I can't put that up there. 27, can't put that up there. 29, I can put that up there. Okay, so 21 breaks down into 3 times 7. And now you can see that 3, and 7 are all prime numbers. There's a 3, there's a 7. So I don't need to do any more on this one. So its prime factorization is equal to 3 squared times 7. Is okay? So our ability to be able to factor, break a number up into a couple parts, and to do prime factorization is really important as we go further on in mathematics. So we have to have these basic skills. So here's some of the, like I said, some basic factoring things that we're going to do. Now what happens if I have something like this, 210, and I'm trying to break that down into its prime factors? Well, let's try and factor it first. We know it's even, right? So I can always do 2 and 105. And then 105, well, that's got a 5 in it, so we know that it has to be divisible by 5. So 5, and that's 21. And then 21 breaks down into 3 and 7. And that pretty much, that's prime number, that's prime number, that's prime number, that's prime number. So its prime factorization doesn't have anything that we can put together back again with an exponent. It is 2 times 3 times 5 times 7. And what that tells me is that there's not a common prime number in there. And common primes, when we had 2 cubed or 3 squared, is going to be really important when we start dealing with things called radicals later on in this course. Okay? So hopefully we're doing okay right now with some of those prime factors and what factors are. So the next thing I want to talk about is how do we factor with something called a GCF or an LCM. Okay, so GCF is what we're going to look for is, let's say I have the numbers 14 and let's go 35. 14 and 35. So greatest common factor is the biggest factor that goes into both of these things. Biggest factor that goes into both of these things. So what I might want to do is I might want to break down into my prime factorizations. This is 2 and 7, and this is 5 and 7. And you can see that they have a common factor of 7. So 7 happens to be the greatest common factor that goes into both 14 and 35. Okay? Now, if we had a number like this, let's try this one. We'll do one more down here. Let's say 20 and 30. Say we're doing 20 and 30. So 20 I break down into 2 and 10, and this 10 breaks down into 2 and 5, and 30 breaks down into 5 and 6, and 6 breaks down into 2 and 3. Then you would see that they both have common factors of 5, but they also both have common factors of 2. And then what we can say is the greatest common factor between 20 and 30 is actually 10. It's the product of those two things. So we're looking for the biggest numbers that can go into both of those. Okay? So the reason that's important is when we go to factor, let's say a polynomial. Polynomial is a addition or subtraction of individual terms. Let's say I have this. I have 15x cubed plus 20x squared plus 10x minus 40. I have something big like this. What we want to do is see if there's a greatest common factor in that. And if we can, we want to pull it out and make it smaller. Okay? So being able to remove stuff out of a polynomial. So I would look here. I've got a 15, a 20, a 10, and a 40. And those are all numbers that end in 5 or 0, which means 5 has to be able to go into all of those things. Now I could break all these out and do all the prime factorizations, and I would see that 5 is the only common thing with it. or hopefully I just kind of know because those numbers are pretty basic right now. So I could pull a 5 out of this. Now I look, can I pull x's? Well, this has 3 x's, this has 2 x's, this has 1 x, and this doesn't have any. So there's not common x's to any of these terms, so the most that I can do is pull out a 5. So then I ask you what's left. Well, it should be a 5 is pulled out, and then I'm left with a 3x squared, because when I divide 5 into this 15, I'm left with 3x cubed. And I didn't pull any x's out, so they're all still there. So 5 times 3x cubed, and then I've got plus 4x squared plus 2x minus 8. And now I've shrunk this thing down to something smaller. And one of our goals as we do math is to be able to simplify expressions, equations, whatever we can do. If we can make something smaller than what it looks like, that's a good thing. So let me do it again on one more of these things and see if this helps for you. Okay, so let's take this. Let's go 20x squared y. Ooh, put another letter in there. Don't let that scare you. It's just a letter just hanging out. Minus 10x squared y. And then I'll put a z on that one. So I'm looking for common factors to this, and I'm going to look for two different ways. I'm going to look for numbers that are common, I'm going to look for letters that are common. I'm going to pull them both out. So you tell me kind of in your head, between 20 and 10, is there a common factor there? And hopefully you said it's 10, right? 10. So that means I can pull a 10 on the outside of my new set of parentheses. Now I left some room there because I think there's common letters in here too. So would you agree there's an x squared in both of these terms? And if there is, I can pull it out. Is there a y in both of these terms? Yep, I can pull it out. Is there a z in both of these terms? And the answer in that case is no. So I can't pull a z out of here because there's not a z in this one to be able to pull it out of. Okay, so this right here, this thing that I'm able to pull out, is called the greatest common factor of these two expressions. So now what I want to ask you is what's left? So what would go back inside this parentheses if when I multiplied it by 10x squared y, it would equal this thing right up here? And the answer is, of course, just 2. And then there's a minus sign, because 10 times negative 1 technically is going to give me negative 10. X squared gives me x squared, y gives me y, but I do need a z. So z is the only thing that's left with the negative sign that's there. So a common factor that I was able to pull out here is 10x squared y, and then I've got 2 minus z. And that would be my final answer right there. If I was to, say, break this down into these two factoring things. Okay? So again, in summary, factors are any two numbers that multiply together to equal an original number. Prime numbers are all the numbers that are only divisible by 1 in themselves. And we can do something called a prime factorization. When we have prime factorizations of these numbers, they are going to help us hugely when we start dealing with these things called radicals later on. There is something called a GCF, which is the biggest factor between two numbers, between like 14 and 35. And we can also use GCFs with extended polynomials like we just did. Now, lowest common multiple is kind of like the opposite of GCF. So 10 and 12, I'm going to kind of sneak this in here in the middle. The lowest common multiple is the number that is equal to or bigger than 10 and 12, but the lowest possibility thing that it is. So, let me throw a few out here. Let's see here. Let's go 24, 30, 36, 60, and 120. We know the biggest thing that it could be is 120, because 10 times 12 is 120, right? Okay, but we want to look for the lowest thing that has common things to it. That's a multiple of these two numbers. Okay, so how do I'm going to tell you it can't be 24 because 10 and 12 don't go into 24. It can't be 30 because 10 and 12 both don't go into 30. And it can't be 36 because 10 and 12 don't both go into 36. I will tell you that I believe that it might be 60 right here. Now, question is, why is it 60? Well, 10 goes into 60 evenly, and 12 goes into 60 evenly. Like I said a second ago, 10 goes into 120, and 12 goes into 120 evenly, but this one is lower than this one. So it's lower, and it's a lowest common multiple. Now, how did we get 60? Where does that come from? Okay, so what I'm going to do is I'm going to go 10 is 2 times 5, 12 is 3 times 4, right? And 4 is 2 times 2. So those are all of its factors, yes? Those are all of its factors. But they're kind of split right here. So you can see that this 10 has a 2 and this 12 has a 2. And if I just scribble one of them out because they were repeated on both numbers, I have these 4 numbers left. And what is 3 times 5? 15. Times 2 is 30. Times this 2 remaining is 60. So what I did was I took the one factor, just one of them. I don't want to kill them both off. Just one of them. I took one of the factors from here and realized that it was also in here and said, let's not count it twice. Let's only count it once. If I was to count it twice, that's where the 120 would come up with 2 times 160. Okay, so hopefully that's good. Hopefully that's a great review for you on factors and prime factors and GCF and LCM and being able to factor polynomials. That's going to be huge as we move into the ability to factor quadratic trinomials. And quadratics have lots of relevant specific mathematical applications to things that we'll see in our world. And we're going to get more into quadratics as we go. Okay? So this is our first one. There'll probably be some problems for you that I'll put up for you to practice on and make sure that you guys can do that stuff. And hopefully some of this was kind of even review. Good deal. Talk to you guys later. Bye.